Alô, alô, alô.
Is it? Yeah, now it's working. Okay. Good morning to everyone. Good morning to everyone. I know that there was a bit of a delay with other sessions, so we waited a little bit more. My name is Emma Fabrega. It's not Sarah Hinz. Unfortunately, Sarah was not feeling well enough to share this session, so I'm replacing her. And I am really happy and I really thank you for being so flexible in behavior. We learned yesterday we synchronize our behavior towards music, and you demonstrated today that you can synchronize behavior to, you have this flexibility to be here, to listen to this last session, which is going to be very exciting because it's going to move us within different species from we are starting with mice, then we have Ming to laying hens presentations, one in dairy heifers, and then we'll move virtually to South Africa to listen about elephants, all of them with a common topic to deal with abnormal behaviors and damaging behaviors. So I must say that I am a pig person, so is that a new species? I'm not going to be the one doing any smart question. It's up to the audience. I know that they will be the questions. I will just try to assist you to keep on time. So, you know, you have 15 minutes, and then when you've done 10 minutes of talk, I will just show the yellow sign. And after these 12 minutes, I will show you the orange sign to like leave 3 minutes for discussion and to change rooms. So without any further delay, we start with our first speaker, Anna, who is going to talk to us about stereotypic behavior in mice. Thank you, Anna. The floor is yours.
Thank you so much. So hi, and thank you so much for being here this morning. I'm super pleased to see all the people trickle in. My name is Anna Ratuski, and I'm a PhD candidate at UBC in the Animal Welfare Program. And today I'm going to be talking about playpens for mice. And since there's not a lot of rodent people at this meeting, just to introduce you to how we house mice in laboratories. This is called shoebox housing typically. This is a conventional cage that you would house laboratory mice in. It's typically about the size and shape of a shoebox. And they would have some sort of bedding on the bottom of the cage, and then usually some form of nesting material and a shelter is generally the standard. But these cages don't allow for a large repertoire of natural behavior for mice. And these cages are generally associated with higher rates of morbidity and mortality, behaviors that are indicative of anxiety or depression, higher rates of stereotypic behavior, and higher rates of agonistic behavior. And this is when you compare these mice to mice that are living in more complex environments. And so I'm going to be focusing on stereotypic behavior and agonistic behavior today. And so this is a couple of examples of what stereotypic behavior looks like in laboratory mice. So you're going to focus on the gray mouse at the front of the cage. She's twirling on the wire lid, so just going repeatedly in circles, hanging off the wire lid. And then the next clip you're going to see is an example of bar mouthing or bar biting behavior. So it might look like they're eating the food, but they're actually chewing on the metal bars. And they typically do this up near the top of the cage or in the corners. And this has been potentially linked with motivation to escape the cage. Other behaviors that mice tend to do in lab environments are backflipping, circling on the wire lid, and route tracing. And they tend to spend about 10% to 15% of their active time doing these behaviors. The next video is an example of some agonistic behavior. And so you're going to focus on the gray and the black mouse. And this is actually sped up. But these are female mice. And so this is an example of what aggression might look like in female mice. It's a lot of anogenital sniffing, some chasing. Often females will do more dominance behaviors like mounting, but it can escalate to attacks and actual fights, which is a welfare concern in an environment like this where there's no physical separation in the cage and there's not really anywhere for them to get away and de-escalate the situation. And that's when you might lead to wounding. So more of a welfare concern. So despite all of these welfare concerns in these environments, these cages persist in part due to the tradition of them, the convenience of them, and the obvious economic reasons. It would be very expensive to change the entire way that we house mice. And so our lab has suggested that maybe we could use playpens. So giving temporary access to enrichment might be a viable approach to improve welfare. And so this is a video of our mice in our playpen. So we made this out of a rat cage, actually, connected to another rat cage. And one of them had all of these components in it to allow for exercise, running, climbing, sniffing. And then this cage is full of burrowing substrate. So the mice are able to engage in burrowing, which is a really popular behavior for them. So they're able to do this in this environment, which they can't do in their home cage. And so in our first experiment with playpens, we found that mice are really motivated to access these environments, and we found that it was a positive experience for them. However, we didn't really look at how it impacts their welfare outside of this environment. And so that leads us to our current research question of how playpen access impacts the welfare of mice that are still living in shoebox cages. And so for this, we predicted that mice with playpen access would develop fewer stereotypies than control mice that stayed in their home cages. And we also predicted that mice with playpen access would display less aggression following a stressful event. And for us, that was cage changing. We used 14 cages of female mice, and we housed them in these mixed strain trios. So you see the strains along the bottom of the slide. We had DBA, Valb, and C57 Black 6 mice, which are all commonly used strains in biomedical research. We had 7 cages receive playpen access, and we had 7 cages that were controls, and they stayed in their shoebox cage for the duration of the study. So we had 42 mice in total. The mice that received playpen access got to go 30 minutes per day, 3 times per week, regularly from about 5 weeks of age to about 14 weeks of age. And we recorded their behavior in their home cages using a video system. And we scored their stereotypic behavior using 0-1 sampling in the dark when they should be active. And we scored aggression continuously following cage changing on 3 occasions, also from videos. What we found is that some stereotypies were more common than others. So this is showing the most common stereotypies that we saw in our mice: bar biting, circling, and twirling. And so on this plot, each dot represents a mouse and the black bars represent the means. And we see that Valb mice and DBA mice, the white and the gray, were more commonly performing bar biting. We more commonly saw circling in C57 Black 6 mice. And then we saw twirling more often in the DBA mice. So we had some genetic differences there in what stereotypies they were performing. And the other thing I want to draw your attention to is the fact that the playpens did not decrease stereotypies in the playpen mice. And so what we found is that the playpens actually had the opposite effect. So playpen mice were performing more stereotypies than the control mice. And this is driven, again, a little bit by those C57 and DBA mice. And so there's a few reasons why we think we found this. Firstly, that playpen access could have increased their motivation to escape the cage. So knowing that there's something else out there that they could experience that was interesting to them, it might have increased their motivation to explore and get out of that home cage environment. The shoebox cages also could have had a more negative impact on their emotional states if it led to frustration and feeling like they've lost out on something, having enrichment taken away from them. And then lastly, we think that the playpen mice could have been more actively coping. So if they were stressed about their home cage environment, they could have been showing it more through active coping, whereas it's possible that the control mice were more passively coping or more anhedonic. For agonistic behaviors, We mostly saw anogenital sniffing, and so this is not really an overtly aggressive behavior. We saw things like fighting incredibly rarely. And so this is, again, because we're working with female mice, we don't expect to see a lot of aggression. However, we did see an interaction between strain and treatment. So the C57 Black 6 mice, if you work with mice, you might know them as being sort of bullies. They do tend to be the more aggressive mice compared to the other ones. And for these girls, we saw more aggression, and we saw more of a treatment difference there as well. So more aggression in the control C57 Black 6 mice and less in the playpen mice. So potentially a benefit for strains that are more aggressive, whereas we didn't see much of a difference for the other ones, but we also had pretty low rates of agonistic behaviors. There are some limitations to this study. Firstly, that indicators of emotions or anhedonia would have aided our interpretation of what the stereotypies are telling us. We also are focused on female mice only, and so that's only half the picture. I think it would be really important to try this with males, especially when looking at things like aggression, which is more of a welfare concern. And lastly, this is only one study. And so we did 3 times a week for 30 minutes, but maybe that's not the ideal rate or frequency or duration. And so perhaps there's a more ideal way to provide playpens for mice, or perhaps this is not a good strategy and it's not possible to provide good welfare to mice that are living in these environments and only getting sort of this dose of a complex environment. The take-home messages here are that, contrary to our predictions, temporary access to playpens did not mitigate stereotypic behavior for mice that are living in shoebox cages. And in fact, we actually saw a bit of an increase. However, the impacts on agonistic behavior varied by genetic strain. And so maybe there were some stress-reducing components of it for some strains. And I think that this would likely vary if we use male mice as well. And while the playpens provide some benefits, such as increased opportunities for natural behavior, they might also make living in a shoebox cage more perceptibly negative for mice. And so it is possible that this is decreasing their welfare if they are now perceiving their home environment more negatively. I want to thank all of our undergraduate volunteers and research assistants, and of course, all of our mice. If you, oops, sorry, the arrow got moved a bit there, but if you do want to read about this, we published the first experiment on it. So that is open access and available. And I'm happy to take any questions.
Thanks a lot, Anna, for keeping on time and for this very nice talk. So let's go for the questions.
Thank you, Anna, so much for a fabulous talk. Beth Ventura, University of Lincoln, sorry. Jesus. Yikes. I was wondering if, and I'm sorry if I missed it in the first couple of minutes because I was a bit late, if you have considered maybe announcing the impending kind of vacation in the playpen and seeing if that maybe has some kind of effect.
So we did that in our first experiment. Okay. We looked at anticipatory behavior. And so we found that we had this significant increase in anticipatory behavior once mice knew that they were about to go to the playpens, and they also went there more quickly. So we compared their latency to enter them on day 1 versus days 3, 5, 7, and throughout. And after they had gone a few times, they were essentially running to get there. So we'd put a little tunnel in their cage and they would sprint to the playpens. So that was really cute. But yes, we looked at anticipation as well.
Hi, great study. My name is Rachel Park, or Cadell. I'm from,
geez, this is hard. It's been a long week.
And I'm from North Carolina State University. I loved your study, but I just want to know, like, what would be your next steps? So would it be looking at that male population, some of those more specific breeds, or would you want to look at like a different frequency, like you said, like daily, or just what do you think? What would be the most interesting to you?
I think it would be interesting to try this with males, but you do run the inherent risk of they could fight a lot. And then that's also a huge concern if you have animals that are wounding each other. So we're a little nervous to try this with a large population of males. I think it would be interesting to try it in the way that we know a lot of technicians are actually using playpens, is they put the animals in there. Usually people who are working with rats will put them in there for like 1 day at a time. And so that's really different to how we were doing it. And so I think it would be interesting to actually test how people tend to be doing it in practice, at least people that I've spoken to.
Hi, Janja Scheronik from Met Uni Vienna. Thank you for a nice talk. I was wondering, why did you mix different strains, and is that a common practice? I don't know. And do you think that might have an effect, because you actually provided something good, which is playful this experience, but you house it with bullies. So maybe the other two strains would show different behavior if they were not, with the black mouse.
Yeah, thank you for your question. So housing the different strains together, I would not say is common, but it's sort of a strategy to try and increase the variability of your population in sort of a controlled way and look at those genetic impacts. So we saw such big differences between the different strains and different behaviors that I think it's important to do that, especially since if we'd only used one of these strains, we would have missed that part of the picture. So I do think that is important. And sorry, I forget the second half of your question. I think not necessarily for stereotypies, but potentially for the agonistic interactions, since we do have the one C57 black 6 mouse in each cage, and they tend to be giving out a lot of the aggression, and then the DBA mice tended to receive a lot of that aggression. And if we had housed maybe 3 DBAs together, it would have been a different sort of dominance structure.
Hi. Carly O'Malley from Charles River. I was wondering if you have any plans to keep the mice in those cages as their home cages and see if that has any difference, or if that's possible in your study.
I would love to do that. I don't currently have plans to do that. I would absolutely love to do that, especially in the burrowing substrate. So we actually did a follow-up study just briefly where we housed mice with cages that were full to the top with burrowing substrate. And so they had 24/7 access to that, and they used it a lot. And so I think that's really interesting. That was sort of my favorite component of this project.
Okay, thank you. Sorry, I think we need to move to the
Thank you
next
so much.
presentation. You can ask Anna on the way. Our next speaker is Jens Malmqvist. I'm sorry for the the pronunciation, and he's going to talk to us about mink.
Yes, hello everybody. I would like to acknowledge my partners in crime, which are Maria Diaz-Leon from University of London and Janne Winter Christensen from Aarhus University, Denmark, which is the same place I come from. So now we are going to learn something about mink, if I can get this to work. Yes. Mink are housed worldwide in this kind of system for commercial production of fur, and large mink producing countries, I think places like China, also Europe, Canada, and North America, USA. But although mink spend a great deal of the time sleeping in the nest box like this, they also have very active periods. And we have previously published a lot of studies showing that enrichment for these guys during up to feeding, for example, with biting ropes, changing the feeding management, give them more structured feed, it's actually one of the things which can be done to reduce abnormal behavior. So there's a lot of study out there about enrichment. However, still in the current housing system, there's a lot of different types of abnormal behavior. And this is what we are going to talk about today. Yes, although abnormal behavior are related to reduced welfare, are indicated of stress, there are also some studies showing that might be some positive side effect for the individual doing the behavior. For example, we did a study where we found that if you look at the novel cells formed in the hippocampal region of the brain of a mink, actually we have more novel cells in minks which were high in stereotypic activity. And it fits well with other papers showing that activity may be healthy for some parts of the brain but until now we haven't looked into function, so we tried that in this study. As we heard this morning in the plenary, of course, there's a lot of different things, repetitive behavior and the like. And what we call stereotypies are actually many different kinds of behavior. It's not always that simple to distinguish between what is normal behavior and abnormal. And also there can be some overlap between different types of behavior. I'll give you an example, and I want to apologize that the mink in these pictures look more abnormal than intended. There's some kind of problem when it gets into the system, but let's try to have a look. This is one example of what we see. This is pacing, where you have back and forth movement, which are among the most usual stereotypies in mink, and I will return to that. Then we have more kind of stationary stereotypies. This is what we will call clapping. Also a behavior which can be seen in cats, actually. So we can see, although we call it stereotypic, it has a much different display. And finally, we also see oral stereotypies, as we also heard about yesterday, like this, which is an oral stereotypy. Okay, so even though we call them stereotypies, there's a lot of different, it's not homogeneous. But why should we study these different forms of abnormal behavior? Well, I think it's important because I think we need to understand why they're developed and what is the consequences. Do these kind of behavior have the same development and the same consequence for the animal experiencing it and displaying it? And I think also it's important to understand that this associates some kind of thwarted motivation. So if we understand this, we can do something to prevent it. Yes. And then we should, of course, take action based on our knowledge, right? So what we did was to explore some further questions in mink. And we asked, are different forms of abnormal behavior associated with impaired learning? Are the kind of problem with the brain? Can they learn new things? And can we reduce these different forms of abnormal behavior by giving them access to some sort of enrichment, such as a running wheel? So we screened, we have access to a group of more than 1,000 mink at one farm. And then we made some experimental groups of adult female mink. It took a lot of time and a lot of observation, but I don't have time to go into detail now. But we formed a group of control animals which were free from abnormal behavior, about 35 of these. Then we identified animals having much fur chewing behavior. And I show you a picture of this. This can be seen as removal of hair from the tail. So we can measure the centimeters of the tail affected by fur chewing. And we have 21 of these. And then for the stereotypies, you already saw in the videos, we have pacing, we have stationary stereotypies, and we had oral, the licking one. But being out there, sometimes it's not that easy to, some minks have more than one type. And it also, some are half moving and stationary. It's not easy to distinguish. So we also allowed for a group which have several forms of these, because that's the real life. It's not easy to categorize them always. So we ended up with 150 animals, which were our experimental setup. Okay, then to what we did, we had testing the learning ability. We were interested to see whether they have some kind of dysfunction. And what the mink had to do was to touch these figures, to discriminate between these two figures based on color, position, and then touch it with the nose. And this is a picture from this. It was important in this study that we could do the testing in the home cage, so we have no additional handling of the animal, and we could test many animals. And then we reinforced the correct choice with a reinforcement, a treat, cat food in the opposite end of the cage. So we attract the mink away and they can select a new, in a new trial. And a wrong choice was punished by an air puff. We divided the learning ability in this test into 3 stages: the acquisition, the recall. The recall was after the mink have learned the task initially, the day after we returned and they should do the same again. That's the recall. And then we make it even harder for the final test, the reversal, where we changed the meaning of the 2 figures. So now the correct one was punished. And we have these criterion for passing each stage. And of course, to continue on this road, you have to have acquisition before you can have recall, and you have to have recall before we tested the reversal. So it's a kind of combined test. Each miss, we have limited resources, so we only have to test each individual for 5 consecutive days with a maximum of 13 trials per day. Yes. And we can see all mink, or 94% of all mink, passed the acquisition stage. A lower amount passed the recall, and even fewer passed the reversal. But of course, we also have to say we have a limited time. We only have 5 days. If we continue forever, we have different numbers, of course. One important result is that the mink took the same number of total trials. So there's no difference between groups in how much they participated in this simple test. Well, what did we find? Are the abnormal mink also poor learners? And we did actually see significant difference between the groups. So this is the data for the control groups. They passed an average 1.4 stages out of the 3 possible. And the licking one, they were equally good or bad, you can say. Because one surprise was when we look at the very active pacing and the mixed group, they performed better in this test. They passed 2.1 to 2.3 stages. And then we have a group, the intermediate groupings was the stationary and the virtuous, which were not significantly different from the other groups in the learning ability. Yes, and the last part, we want to see how fixed are these animals in the abnormal behavior. Can it be reversed by giving them, in this case, a running wheel? So this is a picture from the research station where we have some custom, what's happening? Okay, some custom-made running wheels. And we collect data from the revelation on a PC so we can follow how they use it over day and activity and such. So, and previous study have shown when you give mink are willing to work for access for running wheel at a level comparable to swimming water, for example. It's not substituting swimming water, but they will work for access to running wheel, so they have some kind of value for the mink. And also a previous study found that a wheel can substitute stereotypic behavior. However, this study did not distinguish between the different forms of abnormal behavior. And that was actually what we are after here. Are they equally good for the different forms of abnormal behavior? And then you, of course, may question yourself, is running in a wheel just another stereotypic behavior? Well, there have been written reviews about that, so this is a point of discussion. But I think one interesting thing is the study by Meyer and Rubers, who put a running wheel out in nature and then observed wild mice use these running wheels. So I think this is kind of a fun fact. It will be used also in nature, whereas stereotypic behavior are not observed in nature. So this is a mink using the wheel, just to give you an impression of how it looked like. Yeah. So what happened? These figures shows the activity in the running wheel, rounds per day, and we have day 0 is the first day they got access, and they had it for 10 days. And then you can see the groups here. The group shown, the black one is the control group, which was free from abnormal behavior. And then we have the virtuing is the white one, and the licking one is the other one. It may be hard to see, but all these groups use the wheels at a similar amount of time extent. One interesting thing also is that some of these mink were 1 or 2 years old and have never been experienced to a running wheel before, but immediately at day 0, when they got it, 9 o'clock, they use it 9:15. So they immediately use. I use 10 days because I think that would be kind of a habituation period, but that was not the case. Then we look at the other groups, which are the stationary, the pacing, and the mixed group, having more than one form. And they are in a higher level of use of running wheels. This was actually a bit of surprise to us because usually you will distinguish between the stationary form and the pacing form, but also the more immobile form would use the running wheel to the same extent as the pacing one, running back and forth. So that was a bit of a surprise. If we convert that to meters per day, in average, the control mink ran about 400 meters per day, whereas an average group mixed mink ran more than 2 kilometers per day in these wheels. Yeah. What about the different reduction of stereotypic behavior? We observed the proportion of time the mink used prior to feeding, where they're mostly active and where we see the abnormal behavior. How large amount did they use it without running wheel and with running wheel? And this is the result that during running wheel access, pacing were reduced significantly, stationary stereotypies was reduced significantly. However, the licking is something different, it seems. Licking were not affected by the access to the running wheel. So this is a new thing. So maybe licking is something quite different from the other stereotypies. Yes. So in conclusion, I think now we know that learning performance can differ between these minks, and to our surprise, but maybe in line with the studies showing that the brain have more novel cells, we find that the very active pacing and the mixed ones, they actually outperforms the control mink and the licking stereotypies. So they appeared better learners. All mink used the running wheels, but there was a huge group difference, and all the stereotypic behavior except for licking were reduced during access to wheels. Thank you.
Thank you, Hans, for this very nice talk too. So we have time for a couple of questions. We've got one there.
Hanno Wirbel from Bern. Thanks for a nice talk, interesting results. So I was wondering how the mink performed in the running wheel. So did you see that they were using these in a stereotypic way, or was it normal activity?
Yeah, we did not have an observation on the running wheel behavior, so I cannot answer you. But my impression is, like you saw in the picture, that they were not, they were acting also explorative when they got this new wheel. So it doesn't seem like stereotypic behavior, but it's very hard to say, because if they're running very fast, it is hard to say whether this is stereotypically or not. So I don't think we have the answer. But of course, we have additional measures like stress hormones, cortisol, and also their temperament, fearfulness, and so on. So I think it's very hard to tell, actually. So it's a good point.
So our last quick question.
Sabine Gebhardt from University of Bern. Do you think that while some mink are smarter than others, and the smart mink can cope less well in these housing, and so they develop these stereotypies? Or do you think that this stereotypic behavior induced this higher learning ability? So did you have any measure of the mink before, how smart they were before they maybe came into this housing?
No, these mink were kept under kind of commercial production system for more than 1 year. So no, we don't have any previous knowledge of that. I think also that this raised a question on the control animals. When you have mink not performing, they have been exposed. They've seen like kind of management, same housing, same feeding. And then when we have some animals not being passive and presumably normal, so it also questions some of that, whether we should have additional indicators and not only rely on stereotypic behavior as the indicator of. I think activity actually can be a good thing, and it for several reasons. But it seems like things like licking is a complete different league, and it's also a very rare. I have to say it's very rare to see. So these are the extreme animals we look at. So we have to do more on that.
Thank you. Thank you. I think we need to move to next presentation from Sabine. Yes. So now Sabine Gebhardt is going to introduce us some new results on toe pecking in line hens. The floor is yours. Sabine.
Thank you. So I will be talking about laying hens. And first I want to show you the behavior. Please focus on the hen in the yellow circle. And you can see that it's aiming for the toes of the hen next to it. This moves away, and then she's moving further to the next hen. And you can see how vigorously she pecks at the toes of this hen. And she also moves away. And now we will leave this vicious scene. Okay, now this is really a serious behavioral problem, because you may find in a quarter of the affected flocks that 10 to 75% of your animals are affected by injuries due to this pecking behavior. And this also amounts to a high mortality within your flock. So per week, farmers can lose up to 60 hens in a flock of 6,000 hens. And last year in our experimental flock, we lost more than 10% of the hens due to toe pecking. This is not only bad for the hens themselves, but also to the farmer, because it looks terrible when you walk into the barn and you see blood stains everywhere. It causes very serious injuries, which may heal. And on the left, you see this poor female, and there the bare bone is left in one of the toes. Despite these grave consequences, toe pecking has been neglected in the literature. So when I did a literature search in July, there were about 10 times more publications on feather pecking than on toe pecking. And the publications in toe pecking just started to appear in 1990. And you kind of wonder if it was always present, but then you cannot imagine that it has been missed because the consequences are so severe. Well, the little literature that there is, it says that it is a cannibalistic behavior. And one study also linked it to a high physiological stress status of the birds. Unlike a feather pecking, where hens peck at the feathers of other hens, these birds also peck at their own toes, besides pecking on the toes of other birds. And it's very a different behavior, because flocks that have this problem with toe pecking, they often have perfect plumage, so they don't have feather pecking. So since this is now an emerging problem in a lot of Swiss flocks, we did a survey together with Gallo Swiss and send out online questionnaires to more than 500 egg producers. And we got back 96 complete questionnaires that we analyzed. Just by coincidence, exactly half of them, those producers reported toe pecking, and the other half did not have toe pecking, because we wanted all to respond and answer general questions about the management, the hybrid, and the type of barn they had. And then when they ticked the box that they had toe pecking, then they were led to additional questions about the prevalence and what they did against it, and what the farmers thought was the cause of this abnormal behavior. I analyzed these results with univariate and multivariate models, and toe pecking was modeled as a binary variable in generalized linear models. Well, the first thing is that it mainly affects white hybrids, and you have that one exception of one brown flock, but yeah, you don't normally see it in brown flocks. It starts with the beginning of egg laying. So you see when the birds come into the barn. And it's very rare that if you don't have it at the peak of lay, that it would appear later. But once you have the behavior, it is displayed when they lay a lot of eggs, and it might get better at the end of production. So we asked the farmers, what do you think are the causes? And then a lot of farmers said there's something wrong with the hens. So maybe they have very dry skin, then the toes itch, and then they peck at it. And then later other birds are attracted to the lesions. Other farmers thought, well, it could be from the barn equipment that the birds hurt their feet. Others thought that maybe if you have direct sunlight in the barn, this might trigger this behavior, or if the flock has a very high egg production very early on and eat not a lot during the start of lay. Some also put it on the rearers and said, well, it was already present when I got these animals, or it could be mites, nervousness, or feather pecking. Well, when we come to the results of the survey, we found that if the farm had a history of infection with E. coli during the past 5 years, then this increased the chance that they would show toe pecking. Also, when the barn had metal slats in the aviary, and these were mainly all aviary housing systems, versus plastic housing, the flock was more likely to show toe pecking. And also, if there was sunlight directly in the barn, this also increased the risk that the flock would show toe pecking. High frequency lambs are getting more and more frequent, and we were surprised to find out that this also was a risk factor for toe pecking. And there are reports that often the frequency of these high frequency lambs is not the same as you see on the package. So often they malfunction, and indeed they could flicker, and this would be nice to look at. So we asked the farmers, what do you do if you have this problem? And so they did several things like adding enrichment, dimming the lights. They add litter or put something in the feed or water. And then we also asked them, well, do you have the impression that you had less toe pecking then, so it was getting better? Or was it equal, nothing happened? Or was it getting worse? And then I analyzed that. And so for these 3 procedures, dimming the lights and just switching off the light at certain parts of the barn was pooled. And then litter enrichment, because we had enough farms that tried out these things. And like with feather pecking, as only dimming the lights had some effect that you saw less toe pecking afterwards. All these other measures did not seem to have an effect. So again, now we can ask, what can we say about the causes? We have no evidence whatsoever that these birds that have this problem have a drier or scalier skin than a normal laying hen does. There are some indications that there could be injuries from the barn equipment, because we saw more flocks with toe pecking in aviaries with metal slats versus plastic slats. So there could be something to it. Also, if the sun shines directly into the barn, might increase the risk of having a problem with toe pecking. But we also looked at the egg production, and there was no evidence that this was linked to toe pecking. We also looked at feed consumption at the start of lay, and there again was no evidence. And also, well, this was not a systematic approach, but we asked the rearers, and of course they said that it's not present in the pullets. We also didn't find any that there were more mites or a nervous flock, or that these flocks would have any problem with feather pecking. So to conclude, toe pecking seems to have a lot of similarities with feather pecking because it's multifactorial, right? And it seems to be associated with stress factors like infection pressure. And even though we didn't know if those affected flocks really were infected with E. coli, but farms that had a history of E. coli, they had a higher risk of having toe pecking. There is clearly a genetic effect. because we only see it in white hens. And as with feather pecking, if you reduce the light, you reduce this abnormal behavior. But if you reduce the light, you reduce all kinds of behaviors. So that's not very specific. And we have to note that these affected flocks had perfect plumage. So there was clearly no evidence for feather pecking. So for the future, toe pecking is even getting more and more important, because at least in Switzerland, we have predominantly white hybrids and they are prone to toe pecking. We house these large flocks in non-cage housing, so there can be a lot of damage once they start toe pecking. And there's no beak trimming in Switzerland, and also in Europe increasingly, you should not beak trim your birds. Despite of the importance, there are hardly any experimental studies which would be necessary to look into the causes. And I think one of the most important problems are that if we have abnormal behaviors like feather pecking, then we try to reduce the symptoms, for example, by breeding against feather pecking, but this is just attacking the symptoms and not the causes. And so if we now don't have the problem with feather pecking so much in the white layers, we have new problems that emerge. And this would also tie in a bit with the plenary today, that if you don't try to get at the cause, then you will not make progress. I thank you very much for listening, and I thank everybody who was involved in this study.
Thank you very much, Sabine, for an interesting presentation. We have a couple of minutes for questions, so we've got one here, and then.
Hi, thank you for the talk. Lisbeth from the ILVO, Belgian Research Institute. I was wondering if toe pecking is related to the housing system, because you actually found that sunlight in the barn increased toe pecking. So would the free range then also increase toe pecking?
Well, this was done among the Swiss egg producers. And so they have aviaries, and most of them have free range as well. And you have to provide direct daylight in Switzerland. So there have to be windows in the barn, but you don't necessarily have the sunlight shining into the barn. So this could be something that you could try to reduce with curtains or something.
Björn Falkman from University of Copenhagen. Thank you for a nice presentation. I was intrigued by this finding that you don't have feather pecking in the flocks that have toe pecking. Do you have any good explanation for that?
Well, normally you don't do everything. And actually during this Congress, I was sitting next to somebody who told me that she was biting her nails. Her brother was tearing out his hair, and she wasn't wearing jewelry because then she would hurt herself. So I guess you don't have everything at the same time, but it's enough to have one thing that's really bad.
Okay, our last question.
Thank you. I'm Mohammed Bashir Aliu from Ahmadu Bello University, Nigeria. It was a nice presentation. I would like to know if toe pecking is a contagious misbehavior.
Yeah. This is very likely. And because if you have it, then it spreads in the flock. And as I showed at the first two diagrams, it can affect a lot of animals. And so like feather pecking, it is likely to be a contagious disease. And then you have this problem that if you house these birds in big groups, then of course it can do much damage.
What I mean by contagious misbehavior is, are there a tendency that other birds will pick up that misbehavior? Because from the video, it was a single bird that was doing it. Is there a tendency of other birds picking up the misbehavior?
So, I mean, I don't really understand what you're
What I
asking.
mean is,
Okay,
if-
maybe
okay.
you can continue over the
All right.
coffee. Yeah,
Okay.
I'm explaining. Sorry for that, because we need to move to our next speaker. Thank you for the nice talk and discussion. Our next speaker is Saskia, and she's going to continue on feather packing in laying hens. Okay, the floor is yours.
Thank you. It's time for pillow talk. And not only because we're all probably a bit tired because of yesterday, at least I am, but also because it's the name of our research consortium. And I'm very excited to present the main experiment of my PhD project today, which is on light and larvae as early life interventions to prevent feather packing in laying hens. This is the research consortium. It's a European consortium focusing on improving the welfare of both chickens and pigs in low input and organic production systems. So first, a little bit of background. Animal welfare is getting increased attention throughout our society. And this is shown in the way how we keep our animals for food production. In the past, it was more traditional to adapt the animal to its environment. And in laying hens, that is shown by the trimming of beaks to prevent the damage caused by feather packing. However, now the tables are slowly turning and the public pressures farmers to move away from those mutilations. And this has led to the ban on beak trimming in the Netherlands and in several other countries in the EU. And in addition, in organic production systems, beak trimming is not allowed. However, since we're then keeping laying hens with intact beaks, the feather packing behavior, as Sabina already nicely introduced, is still happening. So that's why we need to look for other solutions to this problem. So besides the public wanting to move away from mutilations like beak trimming, there's also an increased demand for more natural products. And therefore, in the poultry industry, this reflects in farmers providing an outdoor area for their chickens. However, an outdoor area also induces certain risks for the laying hens, because there is a higher risk of predation, of infection, and there's also a huge variability in the use of the outdoor range. So we have to sort of prepare laying hens for this outdoor life as well, so that they can optimally use their environment. So where should we look for solutions to these problems? Well, we all learned about the importance of early life experiences. And in laying hens, we know that the incubation environment can influence stress sensitivity. Not only in laying hens, also in broilers, there have been very interesting studies done that show that a light-dark cycle during incubation can actually have positive effects on brain lateralization and can reduce fearfulness. And besides the incubation environment, we also know that an enriched rearing environment can reduce fearfulness and increase cognitive abilities. So what did we do? We wanted to reduce stress sensitivity and the risk of feather packing through a green light-dark cycle during incubation and black soldier fly larvae enrichment during rearing. So a little bit about the methods. We incubated the half of the chicks with a green light, because the green light was seemed the most promising in previous studies. And we had a 12-hour dark, 12-hour light cycle, also based on the previous work. After hatch, we housed the chicks in 44 pens with 9 to 10 chicks per pen. And we provided half of each treatment. that doesn't work. We provided the pens in half of the treatments, these larvae dispensers with live black soldier fly larvae on a daily basis. So we have this 2x2 factorial design with 4 treatment groups. So these are the home pens. This is our student Casper. So Casper is around 1.85 meters. So we have a Casper for scale here. He is teaching the chicks how to use the water nipples. So this was only on the first day when the chicks arrived. This was allowed. And just to give you an idea of how we changed the rearing pens later on to adapt to well, the hens growing, we gave them perches later on, which they really liked, as you can see. So these are the behavior tests we did. Don't worry, I'm not gonna explain all of them, but just to give you an idea of what we did. I don't know why the weeks of age are gone, but these should be the weeks of age. And you can see here that we performed this experiment in 2 rounds due to, well, we didn't have enough space for all the birds at the same time. And then COVID hit in my first round. So we were, yeah, we couldn't do many behavior tests. We could only do in round 2, basically. So I'm going to show you today the voluntary approach test results, the feather scoring, the feather pecking observations, and foraging observations. So first, the fear of humans, we measured in a voluntary approach test. So this is me. The chick started here, but this is a weird one because she appeared not to be very scared of me. We measured the latency to approach, but she actually jumped on my back. And after this, she escaped from the arena. And I just love this picture because it shows to me how much fun it is to work with animals. Always unexpected. So I had sweet corn as bait, and yeah, we measured the latency for the pullet to approach. And we see here a small effect of the light incubation. So the light incubated birds approached 1.29 times faster than the dark. So you see that in those are the purple and the blue lines in this survival plot. However, as you saw, we performed many fear tests, and this is actually the only result that we found. So that's a disclaimer there. I don't want to overemphasize what we found. So we did a novel object test, human approach test, tonic mobility, open field test, and manual restraint test, and that did not result in these effects, unfortunately. Then the feather pecking, we performed feather pecking observations at 5 weeks of age on pen level. And we scored the total number of gentle feather pecks and severe feather pecks. As you see in the graph, we did not find a significant effect here, neither of light or larvae on the number of gentle feather pecks. Though, the graph looks quite promising here, the light larva group, but yeah, it was not significant. And furthermore, there was hardly any severe feather pecking, but we also did not really expect that at this age because that usually starts around lay. But there are indications that gentle feather pecking can be maybe a proxy for later severe feather pecking. We also had a round effect here, which we did not expect. So apparently there were more gentle feather pecks in round 1 compared to round 2. Then the feather scoring, there's a very colorful graph here. What you need to remember is that there was overall very little feather damage due to the reason that I also just explained you, though the chickens were older now, they were 15 weeks, but this is the typical damage that we saw. So it's mostly a separation of the feathers and sometimes a tiny little bite out of it. And also here we had this round effect. So you see that in round 1, there were actually higher damage scores than in round 2. Then lastly, the foraging behavior. So we hoped that the enrichment with the larvae tubes would increase the foraging behavior. So we scored, we did home pen observation week 1, 3, and 7 of age. And we found a small effect here that the larvae-enriched birds indeed foraged more often than the birds that did not receive larvae. However, the total foraging time did not increase. So yeah, you could wonder about that. And also you see it's a very small sample size because we only did this in round 2. So the take-home messages. The early life effects did not show, we only saw minor effects of treatment on behavior. So we found that light during incubation reduced fear of humans, but only in one test, and it did not affect feather pecking. We saw that larvae enrichment increased foraging bouts, but not duration, and there is a low sample size here. And larvae enrichment did not affect fearfulness or feather pecking. So why did we find this? Why did we not find the results, for example, from the earlier incubation studies and all the enrichment studies that we found? It might be that our chickens were too enriched to begin with because of the low group size and the way we did the husbandry. Maybe we should have had a longer photo period of the light dark cycle. There is also one of the studies did a 16 hours light, 8 hours dark. So that might be an option for future research. And we could also think about a different way of scattering the larvae. We found this round effect in some tests, like I mentioned. We are not sure how that's ended up there, but it might be an observer effect. It might be because there was a slight difference in parental stock age. And also during the COVID lockdown, there were fewer people in the stable. And in my second round, there were many more students, and that might have also affected the behavior of the chickens. So these are the early life effects, but it's to be continued because these chickens are still in the experiment at ILVO in Belgium, where the long-term effects of these early life strategies are being studied. And they are also, for example, going to look at the free range use as far as the avian influenza allows it. So this is these are the chickens of my first experiment in their new house. So I would like to thank all these people for the collaboration, and in special I would like to thank my PhD colleague Maeva Manet and my supervisors Bas Rodeburg and Vivian Gerlich and Frank Tuitens, and of course all the animals, also the larvae. And I want to thank UFA for giving me the funding to attend this Congress. Thank you.
Thanks, Saskia, for a very interesting talk. And we have some time for questions now.
Hi, Jan Langberg. Sorry. Jan Langberg from Dummersdorf. One question with regard to these containers. You offered this enrichment by blackfish soldier fly larvae. How does it take, when do you place it in the pen, and how long does it take the chicken to empty or the larvae to come out? So how long does it work as an enrichment tool throughout the day?
Very good question. We gave the larvae tubes in the morning during the normal feeding rounds, and there was a huge variability in how long it took to empty them. So in some pens, it was a matter of, I think minimum an hour, but we did not really score this like systematically, but mostly anecdotally. But we also found that later on in the experiment, the chickens sort of revisited the larvae tubes during the day, which was actually really nice to see that it's a prolonged period. Yes.
Hi, Helen Gray from Newcastle University. Thank you for a lovely talk. I was interested in the graph that you showed for feather pecking, I think at 5 weeks, where there seemed to be much less variation in your 4th group along. And I just wondered if you had any ideas why that might be.
I have no idea. No.
This allows us for the two last quick questions here. No, this Adroaldo and then Mike.
Hello, Adroaldo Zanello, University of São Paulo. Excellent talk. My question is, how did you select the light? I mean, what kind of parameters did you select? And very quickly on the enrichment, also with the larvae, all the animals had access to the larvae, or because the task was not a simple one, then you may have a variability as a result of who accessed the larvae.
So if I understand your questions correctly, a little bit more about the methods of the treatments. So the lights during incubation, we installed it, they were green LED strips. And we installed them like 15 centimeters above the eggs, and it was 400 lux. And about your enrichment question, the larva question, we had 2 tubes per pen, and each tube had 3 holes in them. I should have explained that. So yeah, basically 6 chickens could manipulate it at the time without actually competing, but we did see some competition. So the access might have been hindered at some point. Yes.
I have 2 questions, if possible, but the easy one is if you said you're going to continue, are you going to be using different ages, and would you expect better effects at different ages, anything like that? And my second question, I'll save for coffee.
Sorry, I didn't really, something like ages?
Sorry. You didn't really get the effects you were hoping for with this
Yes.
age. And I was
Yeah.
curious if you're going to be trying older birds, different age ranges, if you would expect different results with different ages.
Well, it was not necessarily ages. Yeah, I mentioned the age that the parental stock age was different from these 2 batches of chickens.
Maybe you can.
No, yeah, no. I think we're studying these chickens in their whole through their whole life. So yeah, I cannot choose a different age. Or do you mean for certain behavior tests?
Yeah.
Okay.
Yeah, you can talk to Mike
Yeah,
over
we'll
coffee.
talk over
And
coffee.
So I think we need, sorry for that, we need to move to our next speaker, who is Blair Downey. We can applaud Saskia again, if you want. So Blair Downey is going to talk to us about dairy heifers and intersucking behavior.
Hi, everyone. I'm Blair Downey. I'm currently a PhD student in Cassandra Tucker's lab at UC Davis in California. And I will be starting as a new assistant professor at the University of Tennessee in January. And the research that I'm going to be talking about today is work that I did with an undergraduate thesis student that I supervised. So intersucking is the licking or sucking of the teats or udder of another animal, which you can see in this video here. So the more black heifer has her head oriented under the white heifer, and she's manipulating the teats. And these are heifers, so these are non-lactating females, so there's no milk being produced as part of this interaction. This behavior is considered undesirable by producers because it can lead to lots of problems, including milk stealing, mastitis, or udder damage. And it's often addressed with interventions that are then considered undesirable for the animals, such as these nose flaps, or animals are also often isolated to reduce this behavior. The conventional wisdom around this behavior is that it's caused by sucking, and specifically restriction of sucking behavior. And that totally makes sense, given the fact that this behavior is sucking, it's oriented at the udder. But there's also lots of evidence that could suggest that solid feed, and in particular, the role that plays in hunger and chewing time, could also matter in this interaction. And related to that, we know that When we consider the amount of time that calves, for example, spend consuming feed, the proportion of time that they spend sucking is actually very low. So they only suck for about 3% of time in pasture-based settings with the dam. And considering the overall amount of time that they spend feeding, that's only about 6% of the time. And the majority of time that they spend feeding is actually devoted to chewing and ruminating, which is based on solid feed provision. This has been suggested as a risk factor for intersucking using survey methods. And we also have lots of evidence that access to forage and time spent chewing does affect other abnormal behaviors in cattle. So it's possible that it would also affect intersucking. Another reason that this might play a role is that we see intersucking across life stages. So we see them in these older age classes that don't typically have access to milk and are often feed restricted. For example, 1 to 57% of heifers are reported to intersuck, and this age class is often feed restricted. Their restriction is typically known as limit feeding, and this is when a nutrient-dense diet is provided at a level of about 1.5 to 2% of their body weight. This restriction is often very long-lasting. It can be anywhere from 1 to 18 months long in both research and farm settings. This is typically done to improve feed efficiency while reducing excretion and rearing costs. It has lots of negative consequences though, because limit feeding does significantly reduce time spent eating. In typical confined dairy settings, cattle will eat for 3 to 5 hours a day, but in limit feeding, due to that severe level of restriction, they're only able to eat for 1 to 2 hours a day. This has lots of negative consequences, including increased vocalizations, increased unrewarded feed bunk visits, and displacements of other animals. We also know that limit feeding can increase some abnormal behaviors like tongue rolling, and heifers that are limit fed will also work to gain more food compared to ones that are fed ad libitum. So we know that they have all of these responses to hunger and limited time spent eating, but we don't yet know if intersucking is also one of these responses. We also don't know how intersucking differs by breed. So we do have evidence that intersucking occurs across breeds, but we don't have great comparisons between the two most common dairy breeds in the US, which are Holsteins and Jerseys. There's some initial evidence that Jerseys spend more time intersucking than other breeds do. And in general, when we compare Holsteins and Jerseys, they are suggested to perform more abnormal behaviors, though this is largely anecdotal. And it's possible that we would see differences because in natural settings, they do differ in the amount of time that they spend grazing based on body weight. So Jerseys actually spend more time grazing in relation to their size, which could mean that they might be more restricted in these common dairy settings. So in light of this, we wanted to evaluate whether intersucking is increased under feed restriction and if there are breed differences in this behavior. For this study, we used 42 heifers that were pair housed in these pens as pictured. They were approximately 13 months old and they were bedded on rice hulls. We used 9 Jerseys and 33 Holsteins. For the first 2 days, which were considered the baseline days, all heifers were fed ad libitum feed, and they were fed this mix of grains and forage here. For the next 2 days, they were then subjected to a 50% feed restriction based on what they had consumed the previous 2 days. And this came out to approximately 1.5% of their body weight. And this is a very severe restriction, but this is very similar to what happens in typical limit feeding practices on farms. So while this is very restrictive, the way that we tried to reduce how unpleasant the experience would be for heifers was to severely shorten how long they were under this restriction for. We applied restriction for only 2 days compared to, again, the 1 to 18 months that they would normally experience this for. They were then provided ad libitum feed again for the return phases. And they were video recorded across daylight hours on the second day of baseline, second day of restriction, and both days of the return period. And we looked at both days of the return period, expecting that because we knew we were making these heifers hungry, there likely would be some rebound feeding on the first day of the return period that we wanted to be able to document. So we scored eating at 5-minute instantaneous sampling scans across all 4 days, and intersucking was scored continuously. To orient you to the results, you'll see that day of the timeline is on the x-axis and the dependent variable, in this case, feed intake, is on the y. These will be box plots. And you'll see in the upper right-hand corner, I'll include the model that was used to generate these results. And also just to orient you to what the box plot will look like, you'll see that this black line represents the median, while the white box represents the mean of the data. The box itself covers the first to third quartiles of data. Whiskers extend to the highest and lowest values that are not outliers. And outliers are those that fall beyond 1.5 times above or below those quartiles of data. And a lot of people use outliers as ways to cut animals out or cut data out of their models. I'm using them here just to describe the variation that we're seeing in these populations. And you'll see that the letter at the top indicates whether they're significantly different from one another. So starting with feed intake, as expected, they eat less during restriction because I restricted their feed availability. But just to give you a sense of the level of restriction, they typically consumed around 11 to 14 kilograms of feed per day during the baseline and return periods. And that was reduced to about 6 kilograms per day per individual during restriction. And you can see that there was this rebound in amount consumed on the first day that full feed was returned. As expected, based on that, they spent significantly less time eating during restriction. So they were eating for about 35% of their time during the baseline days, and this was reduced to only 16% of time of that daylight period during the second day of restriction. And this is very similar to those values I presented earlier. So about 35 to 40% of daylight time is actually approximately 5 hours total over a 24-hour day, whereas 16% of this period is approximately equal to 2 hours per day. So these are very similar to what we typically see in confined and limit-fed settings. Related to that, we see that feed restriction does increase intersucking. So they spend about 30 seconds on average intersucking on the second day of restriction, compared to 7 to 9 seconds across all other days. And as you can see, there's clearly a lot of variability. Some individuals are doing a lot more intersucking across all 3 of those days. And even though intersucking is performed across all 4 days, there was no difference in any of the ad libitum fed days. So clearly we can see that intersucking is affected by hunger. It's increased under feed restriction and immediately drops when feed is restored. This could be a conserved evolutionary response to hunger. In natural settings, year-old heifers would still be suckling from the dam. They would just be doing less of it than when they were young calves. And suckling is obviously a very crucial behavior for survival. So it makes sense that if you are feeling hungry as a heifer, you should orient to an udder to try to gain nutrients. But interestingly, our heifers were separated from the dam immediately after birth. So they actually never had opportunities to successfully reduce their hunger by sucking from an udder. We also found that 88% of heifers across all 4 days performed intersucking, which is very high. And 35% of these were outliers, by which I mean that there were 13 heifers who performed intersucking at much higher levels than the rest of the population. So based on these outliers and the fact that we saw intersucking across all 4 days, it's clear that something else is affecting this behavior, not just hunger. This can't be breed because we saw there was no difference in breed performance of intersucking across any days. It's possible that this could relate to their early life experience. We know across species that barren early environments can have long-lasting effects. And these calves were subjected to early separation, individual housing, limited milk, and limited access to forage, all of which can have negative effects. It's possible that abnormal behaviors could persist. If they're developed in the early life environment, they might persist later in life. And this is commonly what's expected for intersucking, that the common belief is that it develops in the milk-fed period as cross-sucking, which you can see here, and becomes intersucking that then persists throughout life. But again, our heifers had no access to other individuals in early life. They were only paired a week after weaning. So during the milk-fed period, they never had access to other individuals. It's also possible that beyond just the early environment being restrictive, intersucking might be affected by the fact that the current environment is also very restrictive. So in herd settings, they'll actually eat for up to 12 hours per day, which is much higher than what we see in farm settings, even when feed is not restricted, which could suggest that there's something else about how they search for and acquire feed that's not being met in farm settings, leading to this increase in intersucking that we see. So circling back to those first objectives, we do see that intersucking is affected by hunger, but as is always the case, that is not the full story. And we found that intersucking does not differ between Jerseys and Holsteins, despite common beliefs that there is a breed difference. I want to thank the people that helped with this study, and I would love to answer any questions.
Thank you. Thank you very much, Blair, for another very nice talk. We've got time for a quick question. 2 quick questions, because then we need to move to online. One here and one at the back.
Hi, Blair. Great study. Rachel Cannell from North Carolina State University. I had one question. I know you saw that there weren't breed differences, but I also saw in your pictures that breeds could be intermixed in the housing units. Do you think there would be a difference if you had all Jerseys together versus all Holsteins together? Maybe a social learning is kind of what anecdotally these farmers are picking up on, that Jerseys just learn from each other differently.
Yeah, so great point. So breeds were mixed for Holsteins and Jerseys, but Jerseys were never actually paired with other Jerseys, just given the limited number of Jerseys we have available on our farm. And the balancing for this study was done at a broader level for a broader study. So it's possible that we would see differences if we kept Jerseys together. From this broader study, we do see that Jerseys spend less time allo grooming, which could be because they're only ever paired with Holsteins, whereas Holsteins are often paired with other Holsteins. They also do lots of other abnormal behaviors, though. We do see breed differences in tongue rolling and non-nutritive manipulation. So it's possible it would be different if they're housed differently. It's also possible that they are choosing to spend their time doing these other abnormal behaviors in other forms rather than intersucking.
Kamboj from India. Did you see the diet, means the proportion of grains or the forage or the hay, that may also influence the time spent on eating and may affect the intersucking?
Would the proportion of grain and hay in the diet affect this? It's possible that it would. We used what the typical farm diet was for this life stage, which was a lot of forage. It's possible that if you fed a more conserved diet with more grains, that they would spend even less time eating, and that might lead to an even bigger increase in abnormal behaviors like intersucking.
Thank you. Thank you.
Thank you very much. So with that, we need to move to our very last speaker. And we need to move virtually to South Africa now and hear about elephants. So Maud Bonato?
Yes. Can you hear me? Yes, I can. Can you hear me?
Yes, we can hear you. So the floor is yours.
Excellent. All right. Let me share my presentation. All right, let's see. Can you see it? Is it all set up?
Yes, we can hear you and see
all
the
right.
presentation.
Fantastic. Good morning, everyone. And thank you for giving me the opportunity to present some of our preliminary results. In this collaborative effort, we try to assess the welfare of 2 semi-captive herds of African elephants using tail-air cortisol and self-directed behavior. This was a collaborative effort between the African Elephant Research Unit of the National Elephant Park in South Africa, the University of Glasgow, and the University of Stellenbosch. Please bear in mind, this is still a work in progress, and these are results from a master dissertation. So, elephants are one of the most iconic and popular species, attracting visitors to zoos and wildlife parks around the world. However, the social complexity, high cognitive abilities, and behavioral repertoire of elephants make them quite a challenging species to work with and to maintain in captivity. As such, concern regarding their welfare have been increasing, highlighting the need of non-invasive methods to assess their welfare without causing additional stress to them. Measuring the overall welfare of animals is, however, not an easy task, as there is no single measurements of good animal welfare. However, combining measures of stress hormone levels and behavioral observation have become increasingly popular as more and more evidence support them as valid indicators of welfare. Stress is an important biological response for any animals, that it helps their bodies to prepare for fight or flee from a potentially dangerous situation. Elephants can experience 3 types of stress: physical, physiological, or behavioral. And to cope with potentially stressful situation, stress result is sparked in the animal, and the brain body starts to release biomolecules such as cortisol, which is the main stress hormone in large animals such as elephants. The cortisol is then broken up by the kidneys and ends up in the blood, saliva, urine, or dung. Measuring blood, saliva, fecal, or urinary cortisol have thus all been used extensively as standards for acute stress levels of different animals, including elephants. These different measures of acute stress response, although commonly used, only represent a time span of a few minutes up to a few days, as acute stress occurs during a particular time or event and is isolated to that specific incident. A newer approach has thus to be using air cortisol, which can help in the evaluation of chronic or repeated stress. When faced with a challenge, behavioral response to stress are often considered an individual's first line of defense. In particular, self-directed behavior are a form of displacement activity, which includes normal auto-related behaviors such as grooming, scratching, and yawning, but in contexts that are not relevant to the situation. Simply put, they are displayed when an animal has a conflict between 2 motivations, such as, for instance, the desire to approach an object while also being fearful of the object at the same time. They have been observed in a wide variety of animals in the form of yawning in domestic dogs, excessive pruning in birds, and self-scratching in primates, and is now gaining momentum as a way to measure the emotional state of animals. Another example in humans, for instance, when you start fidgeting or you start biting your nail. This is a very good example of self-directed behavior in humans to relate to what is happening to us. In elephants, they have only been touched upon, but never really established or used in an assessment of their well-being. They are mostly trunk-related and include trunk twisting, trunk sucking, and directing the tip of the trunk to other parts of the body. The African Elephant Research Unit has thus been busy validating this welfare index, which can be used by other elephant managers all around the world. Since self-directed behavior are a reflection of an immediate feeling, this facilitates the identification of the source of anxiety. But more than that, as they have been observed in both wild and captive population of elephants, they have huge application potential. In this context, we embarked on the challenging yet exciting project to develop and use a method to extract and quantify air cortisol in the tail hair of African elephants. This allows us to investigate the potential effect of 2 different management systems on tail hair cortisol concentration, but also to attempt to link the expression of self-directed behaviors, or as we call it SDBs, and air cortisol concentration, and finally to determine whether tourist and human interaction affected the rates of SDBs and air cortisol levels. So for that purpose, we used 2 herds of elephants maintained in the Western Cape region of South Africa, namely Dyson Elephant Park and Plettenberg Game Reserve. Both herds are home to elephants in need, whether they were relocated, orphan calves, rescued from culls, or ex-circus animals. They, however, differ quite drastically in terms of their composition and management styles. The herd maintained at Dyson Elephant Park is composed of 8 females and 2 males, aged between 13 and 32 years. This is an ecotourism destination, which offers 2 different experiences to tourists, namely feeding and walks. The rest of the time, the elephants are free to roam within the border of the park. The herd at Plettenberg Game Reserve is composed of 5 females and 4 males, aged between 8 and 32 years. During the day, the elephants are free to roam the 2,000-hectare reserve under the supervision of a guide, grazing on a range of trees and bushes. At night, the elephants are guided back to a camp where they can roam and graze. So the herd only encounter tourists when a tour vehicle passes by in the distance or during horseback safaris, and therefore never come in close contact with visitors. When it comes to the hair samples, they were collected in March 2021. So we collected a minimum of 5 strands of hair with scissors as close to the root as possible without causing any damage to the skin. The hair were then tied into bundles, and the proximal end of each strand was marked so we could be able to identify where they're coming from. All samples were frozen for 24 hours to remove any external contaminants, and they were washed then with a 2:1 chloroform-methanol solution in a heated water bath for 10 minutes and then rinsed with purified water. They were then dried overnight, and then they were sectioned in 2 centimeters sections, and then frozen in liquid nitrogen for approximately 2 minutes and then powdered. And 30 milligrams of that powdered tail hair was then used for extraction and quantification of hair cortisol. When it comes to the self-directed behavior, they were recorded between February 2020 to March 2021, exclusively at the Herne Maitena National Elephant Park. For that purpose, each elephant was used as a focal individual for a period of 30 minutes. The self-directed behavior we recorded as they occurred, and we also recorded the number of tourists, the nature of tourist interaction, general behavior, as well as the nearest person and nearest elephant. To investigate the effect of management style on hair cortisol concentration, the GLMM procedure of R was used. We've heard distance, as in the measurements of the position along the growth axis of hair. Age and sex were entered as fixed factor. We also control for individual variation by adding elephant ID as a random factor. A GLM was used to determine the effect of hair cortisol concentration on the display of SDBs. In addition, the number of tourists present during the observation period and the total number of interactions between visitors and elephants were included in the model to estimate if there was any significant effect on the frequency of SDBs displayed. Finally, to determine if tourist and interaction had a significant effect on hair cortisol concentration, a GLM was fitted using the method previously described. Tourist number and interaction were included as both fixed effects, with tourist number below 199 people per day considered as low and above 200 people per day considered as high. While the number of close interaction were categorized as low below 44 and high when it was higher than 45. We also included an interaction with each other to investigate if the effect of one variable relied on the other. So in total, we collected 101 2-centimeter tail hair samples on 17 elephants. The average hair cortisol concentration was of 8.91 picogram per milligram of hair, ranging from 2.23 to 25.10. We didn't detect any difference between sexes and ages in terms of tail hair cortisol. With regards to the 2 different management styles, we can see that the semi-captive population had a higher average cortisol concentration when compared with the free-roaming population, but this difference was not significant. So there was actually no difference in terms of the impact of management on hair cortisol concentration. At the National Elephant Park, the average hair cortisol concentration was of 8.16 picogram per milligram, while the average number of SDBs displayed per month by an individual was 59.69. And we found that the SDBs had an inverse correlation with hair cortisol concentration, with the highest concentration of cortisol occurring with the lowest frequency of SDBs, and the lowest concentration, the lowest concentration of cortisol occurring with one of the highest total frequency of SDBs. We can also see quite a lot of variation between individuals for both these variables. What we also found when we looked at tourists, the effect of tourist and interaction on hair cortisol concentration is that tourists had a significant effect on hair cortisol concentration. They explain almost 16% of the observed variation in hair cortisol. Higher concentration of air cortisol was correlated with higher levels of tourists. And elephants that experience fewer numbers of tourists had an average air cortisol concentration of 6.67 picogram per milligram. In comparison, elephants that experienced a higher number of tourists had an average concentration of 10.03. Close interaction with humans also had a significant effect on air cortisol, where fewer interactions were found to decrease air cortisol concentration by 33.5%. The highest cortisol concentration was associated with high levels of interaction, and the lowest concentration of cortisol was associated with low levels of interaction. However, we did not find any effect of tourist number and interaction on the number of SDBs displayed. So to sum up the results, for the first time, this study provides evidence that we can actually use tele-air of African elephants as a method to measure cortisol and to decipher the individual's physiological history. We also found no significant differences in air cortisol concentration across the two management systems. And while studies have shown that African elephants experience higher degrees of stress than their wild counterparts, a likely explanation of our insignificant result is that these elephants do not experience the situation commonly associated with distress. Specifically, the individuals from Nice Elephant Park live in an enriched environment, which encourages them to display natural behavior, and individuals are not forced to partake in any activity they do not want to. In addition, level of air cortisol concentration when found to be significantly lower in individuals displaying a greater number of SDBs. These findings suggest that SDB may actually provide an adaptive coping mechanism, therefore helping the individual to cope with a potentially aversive situation. We also found that levels of tourist and interaction did not significantly affect the rate of SDBs displayed by individuals in the semi-captive population. And these findings of our study contradict previous work that found that human interaction induced greater display of abnormal behavior. The stress response of elephants has been shown to increase when faced with the unfamiliar conditions associated with captivity, such as human interaction and high exhibit attendance. The most plausible explanation for result is that the number of tourists and interaction during the sampling period was substantially less than usual due to a national lockdown from March to October 2020 due to the COVID-19 pandemic. Thus, the data using this study may not have been representative of the standard frequency of the previously mentioned factors. In addition, it is important to consider the possibility of adaptation to human interaction, as all individuals at the park have been there for a minimum of 4 years, with the majority being housed at Nice Elephant Park for over 10 years. However, we found that higher cortisol concentration was significantly impacted by this factor, suggesting that the use of air cortisol concentration might be a more reliable method of assessing elephant welfare compared to the use of behavioral logs. So obviously, this is still a work in progress, and we need to get a better understanding of variation between the sex and age of individuals, while also determining a better estimate of air growth rate to create a retrospective calendar of an individual stress response. Although we did try to estimate these variables, we were limited by the number of elephants that were available to us for this study and the time frame to measure air growth rates. Study should also focus on determining differences between true free roaming and captive population of African elephants to investigate if air cortisol levels differ between this management system. This information will be quite essential for the welfare of captive African elephants, as well as to provide a novel method of air cortisol quantification that is transferable to other species. And to conclude, I would like to thank the staff at the African Elephant Research Unit and at the University of Glasgow who conducted the study, as well as management and the guides at Nice Elephant Park and Clatterbone Game Reserve who made this study possible. And I thank you all for your attention.
Thanks a lot. Thanks a lot, Maud, for your
You're welcome.
super nice talk. Unfortunately, we ran out of time for questions because I didn't want to interrupt you during yours. But maybe those who have questions can either stay maybe for longer and make them live, or send them to Maud. But I would like to end this session asking for another round of applause for all our excellent speakers today, and also our technical team. Everything has been working super fine. And remember that now in like 7 minutes, sorry, we'll just have eaten some time from your coffee time. You have like this closing ceremony. Thank you. Thank you, everyone.